So these are some multiplication of exponent laws, how we find the, let's see here. Yeah, power to power. Okay, power to power. We also have a couple of different combining exponents with similar base, that sort of thing. So for the first one, it says, I want to zoom it. No. Blue. There we go. X to the negative fourth multiplied by x to the negative 3, y to the third squared, and all of that to the negative 3.
So we do the inner thingy first, right?
Yep, we want to do the inner one first.
Wouldn't that be brackets?
Yeah, I'm going to do brackets here. So you're going to rewrite this as x to the negative fourth multiplied by write this. So I didn't do a whole lot there. I'm just finding it, making it turn into what it is. Then we have what else can we do here? What happens when we have 3, or we have an exponent that is being multiplied by something that's an exponent? What do we do there? We add. Is it? Double check. Look at your notes right now. What is it for a power of a power? What does it say there?
No, that's the
This is a power of a power.
multiplication.
Multiplication. Multiplication. You should have your notes from the powers of exponent laws.
Did you do that on purpose?
The what?
To mess up.
I was doing what you guys told me to do.
Yeah, that wasn't smart. You did that wrong. How did you get 6?
Because 2 times 3 is 6.
Oh, you're doing the fraction one first. I thought you were doing the other one.
How you
I
get all the stuff? Yeah, so crazy.
Nope.
Yeah. Oh my gosh, you want to have a clue? So scared.
So now I have to do what's still left inside the parentheses. So I'm going to have that would be. Yeah, you can do this on a separate sheet. Stop talking. This isn't a conversation. This isn't a conversation. So combining those two. I have a multiplication straight across here. So I have like bases. Now, this is when you add them. And I still have my negative 3. I almost forgot about that guy. So I have to take this to the negative third. Now here we have powers. Did I already do that? Okay, good. Just making sure I'm not wrong again. So I have that negative third. Now it's a power of a power. So I have y times negative 18 on the top and 10 times negative 3 on the bottom. Now this could be a part that could be a little bit confusing because we have a negative exponent in the denominator. Doesn't that mean that, what would that mean? Because when I have an exponent that's negative, it means put it in the denominator. But now I'm already there. What do I need to do, Mr. Mink? Yeah, I need to flip it. Flip it. Flip it real good. Do, 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 do. So yeah, this definitely a lot of room to work here.
Let's do about 6. Let's do about like you did past 19. Yeah, let's do.
No, just to be safe, we'll do every single other one. 'Cause that sounds good, right? That sounds fair.
All right, number. What's another one that looks gross?
All of them. Number 19.
19 is the only easy one.
2, 3, 4, 5.
Let's do quiet. Quiet. We're gonna do number 11. You have a better suggestion, Stacy? 16. Let's do 16 because Stacy was sitting quietly and raising her hand, not shouting like everybody else. And I just want you to not be saying every thought out loud.
Sorry, it's a bad habit.
It is a bad habit. I need you to work on it, okay? So the first thing I need to do is, obviously what's in the parentheses, but I need to recognize a power of a power. So I'm going to simplify these. I have m to the negative 9th now. Then I have n to the 0. It's just going to be 1. You don't need it, but I'm just making sure that when you're looking at this, and also when I put this on my video, so people who are out today can see what was happening. No, you guys know better. I'm just showing that this is where that went. Performing the power of a power. So then I have 2. Keep in mind that that's what that actually is, okay? That 2 times m to the 4th times n to the 2nd. Do you agree? So that means that I'm going to have to distribute. I'm going to have to distribute that cubed. So 2 times 2 is 4 times 2 is 8. M to the 12th, n to the 6th. So now I just have 8.
Why wouldn't you just make that back?
I could. Do you want to make it? I could.
Yeah, let's do that. That sounds funner.
You go ahead and knock stuff out.
He said he wanted that.
Yep, it is. I didn't say
Okay? Yes, sir. Daniel? I needed to distribute because this here, that 2m n to the 4th is the same as this. 2 times m to the 4th times n squared, which means that I need to distribute this cubed to all of them. Okay? Yes? Because of the division property of exponents.
If you put the 1 over and
So I will do that since both you and Aiden are wanting me to do that. So that would be. So with this, stop tapping. So with this, we had m to the 12th over m to the 9th, and that's the same thing as m to the 12 minus 9th. So the only m's you'd have left are the abundance, or the more m's on the numerator. Okay? Yeah.
So if 12 was negative, would you add those? Like if it was.
Yeah, because that would put it in the denominator.
So that you could like amplitude that negative.
Yes, if it was a negative exponent for all the m's, yes. Miss Marshall? No. So I'm going to let you guys get to it. This one here, we have number 2, just like...
No. Let's do 19.
I want you to try... Here, tell you what. I want you guys to do number 11, and by the time that we're done... What time is it? Okay, yeah, you guys do number 11, and then I'll do it, okay? I'll show you what the answer is.